Hello friends, welcome to Study Algorithms, and today we would be looking at recursion-based algorithmic paradigms. An algorithmic paradigm basically means how you can go about solving a problem. A problem can be solved in many different ways. Check the links in the description below to know more about different algorithmic paradigms. In this video specifically, we would be talking about recursion. First, I will tell you the definition of recursion and what it exactly means. Next, we would look at a real-life example and see what kind of problems can we solve using recursion. Finally, we would be solving a problem in computer programming using the concept of recursion. So, without further ado, let's get started. So, what do you mean by recursion? The common definition of recursion means repeating a step over and over again. But can you really hope to reach a conclusion if you're doing the same thing over and over again? A recursion-based approach, in fact, takes advantage of this fact and even helps you to reduce the size of your code. Some problems in computer science have a repetitive structure, and you know that computers are specifically good at doing repetitive tasks. A recursive algorithmic paradigm identifies this repetitive property and solves all the problem one by one, all the way up to the top. In the next couple of minutes, we would be seeing exactly that. But before going into programming, let me show you an example of how this paradigm actually works. You see recursion around you everywhere. Let us have a look at them. A classic example is when you see some job postings. The job posting says that they need an experienced programmer. To be an experienced programmer, you need a job. To have a job, you need experience, and so on. You are seeing a repetitive property over here, right? Or let us say I have this mobile phone with me. You might have taken screenshots, right? So what happens if I take a screenshot and then I again take a screenshot of the screenshot and I keep doing this again and again. So what I'm doing here is I'm taking a screenshot and I'm taking a screenshot of the screenshot and then once again I take a screenshot. What is happening here is that it is a repetitive structure. Heck, even Google has a hidden Easter egg for you when it comes to recursion. For instance, what happens when you misspell a word and search in Google? So instead of algorithm, I search for ALGORITM. I enter search and it asks me, did you mean algorithm? But what happens when I correctly type in the word recursion? Notice that my spelling for recursion is absolutely correct. So I take this word and I hit enter. What do I get? Google again asks me, did you mean recursion? Note that the spelling is same. Even if I click it again, it still asks me, did you mean recursion? No matter how many times I would be clicking it, I would keep getting the same result. You can go ahead and try this on your own. These are all examples of recursion. But how can you actually solve a problem using this paradigm? All of the cases we just discussed are examples of infinite recursion. That means these cases do not have any end in sight. They will go on repeating forever. But there is also a certain set of problems which are repetitive and still they can be solved. These problems have a terminal condition after which they no longer repeat themselves. We take advantage of that terminal condition and then work our solution all the way towards to the top. You may not believe, but you yourself have applied this algorithm technique at some point in your life. Let me show you how. You want to go out for lunch. You ask your friend, hey Blake, wanna go for lunch? Blake says that he would love to, but he wants to check with Cynthia. Blake asks, hey Cynthia, wanna go for lunch? Cynthia says that she would want to go for lunch, but wants to check with Danny. Now, Cynthia asks Danny, hey Danny, wanna go for lunch? Do you see the repetitive, or I would say the recursive pattern over here? Danny replies that she would want to, but she wants to check with Emilia. Finally, Danny asks, hey Emilia, want to go for lunch? Emilia does not want to ask anyone and she readily agrees to meet. This is the terminal condition which I was talking about a couple of minutes ago. And this will help to eventually solve the problem. Since Emilia agrees, Danny is happy and he agrees. Since Danny agrees, Cynthia is happy and she agrees. Since Cynthia agrees, Blake is happy and he agrees. Now, ultimately Blake agrees with you and you all go out for a happy lunch. Here, lunch was the problem that needed to be solved, and we solved it using a recursive technique. So this is how the general idea of a recursive algorithmic paradigm looks like. If this concept is clear in your mind, we can now move towards an actual problem in computer programming. If you are still confused, I would recommend you to go back to the previous example and just watch it once again. One of the most famous problems in computer programming that is solved using recursion is to find the factorial of a number. So let us take up an example of that. The factorial of a number is given by this formula. This formula means that n factorial is equal to 1 if n is equal to 0, or n factorial is equal to n multiplied by n minus 1 factorial if the value of n is greater than 0. So using this formula, let us try to calculate the value of 5 factorial. So given by this formula, the value of 5 factorial should be 5 multiplied by 5 minus 1 factorial, which should be equals to 5 into 4 factorial. Now we need the value of 4 factorial. So 4 factorial would be 4 into 4 minus 1 factorial, or 4 into 3 factorial. Now we need the value of 3 factorial. So 3 factorial would be 3 multiplied by 3 minus 1 factorial equals to 3 into 2 factorial. Are you seeing the repetitive property over here? So let us keep on moving ahead and then see what happens. So 2 factorial would be equals to 2 multiplied by 2 minus 1 factorial, which should be equals to 2 into 1 factorial. Now 1 factorial would be 1 factorial equals to 1 into 1 minus 1 factorial equals to 1 into 0 factorial. If you look at the formula again, we know that now we have reached the terminal condition. We know that 0 factorial equals to 1. Using this terminal condition, we can work our way upwards. So I would now put this value of 0 factorial into the value of 1 factorial. So then this should be 1 into 1 equals to 1. So now I have the value of 1 factorial. We can put this value back into 2 factorial, which should be 2 into 1 equals to 2. Now we can put this value back into 3 factorial. So 3 into 2 equals to 6. Now we have the value of 3 factorial. We can inject this value into 4 factorial. So this would turn out to be 4 into 6 equals to 24. Injecting this value for the one last time, 5 into 24, which should give you 120. So in this case, 5 factorial is 120, and this is your answer. The paradigm we just used to solve this problem was recursion. We found out a repetitive property, we took advantage of the terminal condition, and then we used it to work our way upwards to solve the actual problem, which was finding the value of 5 factorial. You would often see these kind of a repetitive patterns in a lot of problems in computer programming. Binary trees are especially famous for this. For instance, every tree would have a root, a left tree, and a right subtree. Now, if you take up a bigger tree, then still you would have a root, you would have an entire left tree, and you would have an entire right tree. Even all the smaller trees in this structure, you can find this repeating property again. So this smaller tree has a root, it has a left tree of its own, and it has a right tree of its own. Thus, you would find that a lot of problems that involve binary trees can be solved using recursion very easily. We will discuss more on that later. I hope this video gave you a good insight about how recursive algorithms can be used to solve problems in computer programming. The key thing is to identify the repetitive pattern and find the terminal condition where your loop would end. Otherwise, you would be stuck in an infinite loop and you wouldn't reach any solution. If you found this video helpful, please do consider subscribing to my channel and share this video with your friends, as this motivates me to make more and more such videos where I can simplify these programming concepts for you. Until then, see ya.